All right. Okay. So my research article is aerobic work capacity in young Norwegian men and women. So this research article got published in 1965. So it's pretty old. Okay. All right. Introduction. Men and women exist a wide variation within age groups of the body functions underlying the work capacity. So basically, men and women responded to training differently. I mean, VO2 max, VO2 or heart rate. We men and women differ, and this is partially due to different body size. Now, even though we take same body size, difference still exists. Like when subjects are compared on a basis of body height and weight. So researcher, pointed out that it is important to establish um, the range of variability. For example, difference between men and women, and comparing between athlete and non-athlete. So this basically led to conduct this study. Purpose was to evaluate variability in terms of the aerobic work capacity and related respiratory functions in healthy men, young men and women. So, and this study also involves athlete comparing with non-athlete. Let's talk about method section. So participants, there are 43 healthy participants. So as I said in this study, top athlete and non-athlete were involved. So 19 top athletes and prior to or during the competitive season data was collected. Then I guess some of them were medal winners in Olympic game into 1950 or 1960. So I guess top athlete considered really top athlete, and 24 non-athlete. So considered student. So you can see from table one, top men's athlete 14, and then 12 male students, and then 5 top female athlete and 12 female athlete. I'm sorry, students. So you can see age, height, and weight. Okay. All right. Study design was, I guess, pretty simple. So bicycle riding on ergometer. So ergometer was used for this study, and the pedaling rate was kept constantly. Then load was increased by increasing the braking resistance. Then there was no specific explanation why 2 or 3 sub-maximum work laws were required for participants. I guess some had 2 and some had 3. I'm not quite sure specific reason behind it. And kind of same thing sort of applies the next point here, maximum level by performing 1 or 2 exhausting runs. So I guess some people had the issue by just performing only one time. All right, measurement. Oxygen uptake. Researchers spent really a lot of time talking about oxygen uptake. So sub-maximum and maximum oxygen uptake, and heart rate, and some respiratory and circulated measurement were discussed, but not so much. All right, result. So horizontal line, which is about workload, then vertical line, which is about oxygen uptake, so VO2. So as you can see, as workload increased, like from 600 to 2,400, so oxygen uptake VO2 increased. So as you can see, non-athlete VO2, stopped around 1,500, but for top athletes, the VO2 still increased more. Then around workload of 21 100 torque per minute plateau. So this is one of the research I really wanted to point out to tell. So there is a difference between athlete and non-athlete regarding range of variability. All right, so this shows the oxygen uptake of bicycle riding at sub-maximal work intensities. So you can see there is a tendency toward higher value for oxygen uptake in athletically trained subject. So for example, if you take a look at the top line here, so this is men's athlete, and the second line is hold on, non-athlete in men. So athlete had basically higher oxygen uptake, from 600 to 1800. Then this tendency is true for females. Athlete basically had higher value. So and if you take a look at difference between men and female, so basically men it's higher than female. But one of the things I wanna point out from this table is take a look at line second line and third line, so which is compare difference between non-athlete in men and athlete in women. So there is no difference. And if you take a look at 1200, so actually women's athlete had higher value. So we can't just easily say men is higher than women. So we have to take a look at fitness level to consider. So this explains basically maximum oxygen uptake. So it's kind of same as sub maximum oxygen uptake. So if you take a look at the first line and second line, so comparing between athlete and non-athlete in men, and so for men's athlete had higher than men's non-athlete in terms of maximum oxygen uptake. Then, so if you see on line number 3 and number 4, comparing between athlete and non-athlete in female, so athlete had higher. So, but again, if you take a look at the line, second line and third line, so comparing between non-athlete in men and athlete in female, so you can see the same idea that men is higher. Actually here, women's athlete had higher value, higher maximum oxygen uptake than non-athlete in men. All right, a little bit of a discussion. So basically, oxygen uptake during bicycle, some maximum, and also maximum fixed rate was higher in athletically trained than in sedentary subjects. So, and the reason behind it is athletes generally have a around 10 to 20% higher BMR than sedentary subjects. So this was actually published 1915, whew, 100 years ago. So excellent skills in performance of one type of sporting activity does not necessarily result in greater general ability to perform exercise with the least possible use of energy. Then kind of main key is we should really compare athlete versus athlete, or sedentary versus sedentary, just because if we compare, for example, a non-athlete man and athlete female, that's not good. All right, this is going to be my last slide discussion number two. Maximum oxygen uptake differ among different populations. So it seems to me maybe I'm giving you, a lot of bunch of information as I got a lot of bunch of information from this researcher. So yellow means trained athlete or trained student, and white information means non-trained athlete, sedentary living men or women. Then you can compare the value between trained and non-trained, but in men and women just separately. So you can see trained people have higher value. But again, as I mentioned previously, if you take a look at non-athlete in men and athlete in female, that difference is disappeared. So it's important to take a look at fitness level. So because this research was conducted around 50 years ago, so now we know, but at the time I guess it was kind of hot topic to discuss. All right, then, thank you so much for your time, and I'm happy to take some questions.